Okay, inverse trig functions. There are three trig functions that we learned in first semester. There is sine, which we abbreviate sin. There is the cosine trig function, which we abbreviate cos. And then there's the tangent trig function, which we abbreviate tan. And the definitions for each one of these is as follows. Sine of, and that's the theta symbol right there, is equal to the ratio or the fraction, opposite side over hypotenuse. Okay. Definition for the cosine trig function is cosine of the theta angle is equal to the fraction or the ratio adjacent side over the hypotenuse and the definition for the trig function known as tangent, abbreviated TAN, is tangent of the theta angle is equal to the ratio or the fraction opposite side over adjacent side. Okay, so these are the three definitions that we are going to use in the next three examples in order to create an equation, and then we're going to go over how to mathematically solve an equation with sine, cosine, and tangent. Okay, now, before we actually work out the three examples just remember that this symbol right here, that 0 with the squiggle through it, as you can see, it is a Greek letter, and it is the Greek letter known as theta, where my hand cursor is going over. There we go. There is theta right there, where my cursor is going over. That symbol right there in math, we use that symbol to represent a non-90-degree angle in a right triangle. Okay, so you're going to see that symbol pop up in the first example, and then we're really not going to use the symbol again, but a part of the definitions, that's what it's from. Okay, so example number 1. Let's say that I have a right triangle, and let's say in that right triangle, the vertical side of the right triangle has a length of 5, and the diagonal side of the right triangle has a length of 11. And then inside the right triangle, inside at this bottom right angle here, is you see the symbol theta. Okay, so what we're going to be doing in this problem is we're going to be using sine or cosine or tangent, and we're going to be solving to figure out what's the value of theta. In other words, we are finding this missing angle in this right triangle, the missing angle being this angle where the theta symbol is. Okay, now here's how we do it. We work from the theta angle. The side where the 5 is on, because it's all the way across the triangle from the theta symbol, that side is what we refer to as the opposite side. It is the opposite side because it is the side that is across from the theta angle. And the side where the 11 is on is what is known as the hypotenuse side. Really, we just call it the hypotenuse. Now, it's the hypotenuse because the side that is the hypotenuse of a right triangle is always the side that is across from the 90-degree angle. Now, you can see from my three definitions, the only definition that includes opposite and hypotenuse is sine. So what this tells me is that in example number 1, I am going to use the definition of sine to create an equation, and then I'm going to use a little bit of math. Actually, it's a lot of bit of math, but I'm going to use a calculator, so it's going to seem like a little bit of math to figure out what's the value of my theta angle here. Okay, here's how I do it. My definition says sine theta, okay, I have a theta symbol, is equal to the ratio or the fraction, the opposite side, and from my diagram, the opposite side has a 5 on it, over the hypotenuse, and from my diagram, my hypotenuse is an 11. So this is the equation that I'm going to use in order to solve for theta. Now, what I need to do to solve for theta is I need to mathematically eliminate the sine function from my equation. And the way that I do that is I multiply both sides of the equation by the inverse sine, which we represent by sine with that -1. It looks like an exponent there. So I'm going to multiply both sides of the equation by sine with sine -1, which is called the inverse sine. Now, the reason why I do that is because sine -1 cancels out sine, okay? And you could see that when the sine -1 cancels out the sine, my equation becomes theta is equal to sine -1, and then the fraction 5/11. Now, to figure out what theta is equal to in this equation, I let my calculator do the work. Okay, now, this actually takes quite a bit of math to figure out what is the sine -1 of the fraction 5/11. However, because we have calculators available for us, we don't have to do quite a bit of work. So I'm going to use my scientific calculator. All of you should have a scientific calculator on your desk. So I'm going to activate the sine -1 function. And I'm going to do that by going here, sine -1. And then after I activate the sine -1 function, I'm going to type in the fraction 5/11. And you can see that the answer is, it's a very long decimal, 27.03. When you get a very long decimal for an answer, when you're using sine, cosine, or tangent, always just stop after the second decimal number, 27.03. So that is going to be my answer for theta, 27.03. Okay, so that would be an example of how I use the sine -1 function to eliminate sine from an equation to help me solve for, in this case, theta, which is a missing angle in a right triangle. Number 2, we're going to do 3 of these here. Number 2, here is my right triangle. Inside the triangle, at the top of the angle, I'm going to put the variable x. The vertical side, I'm going to mark as 6. And the diagonal side, I'm going to mark as 13. Okay, so what we're going to do is we are going to identify whether I use sine, cosine, or tangent in this equation, and I'm going to use the definitions. And theta is the angle where the x is. Okay, so I'm working off of where the x is inside the triangle because that's going to be my theta. Okay, now the side where the 6 is on, because it's the side that is touching my x, which is my theta angle, that is what becomes known as the adjacent side. The adjacent side of a right triangle is always the side that is touching the theta angle. The side where the 13 is on, although it is also touching the x, it is the hypotenuse. And we said earlier, the hypotenuse is always the side that is across from the 90-degree angle in a right triangle. So you could see that I have 6 on the adjacent side, 13 on the hypotenuse side. The only trig function that involves adjacent and hypotenuse is cosine. So this tells me that in example number 2, I'm going to use cosine to create an equation, and then I'm going to do some math to figure it out, to figure out the answer. So here's my equation. I use this definition, cosine, and then the definition has theta in it. Now my diagram tells me that theta is x, so I write cosine x. You do not have to write the degree symbol. Is equal to, and now the definition tells me that the adjacent side goes on the numerator, the top of your fraction, which is 6 from the diagram. The hypotenuse goes on the denominator of your fraction, which from your diagram is 13. So using the definition of cosine, using the diagram that I was given, I create the equation cosine x is equal to 6 over 13. And now I use this equation to solve for x. Okay, to solve for x, I need to eliminate the cosine function from my equation. The way that you eliminate cosine from your equation, any equation, is you multiply both sides of the equation by the inverse cosine, which we represent as cosine with that -1 as the exponent. When you multiply cosine -1 with cosine, the cosine -1 cancels the cosine out. And you can see what is left in my equation now is x is equal to cosine -1 and then the fraction 6 over 13. Okay, and now to figure out what x equals, I use my calculator, and it's actually a lot of math, but it's going to seem like a little bit of math because I'm using my calculator to figure out what is the value for the cosine -1 of the fraction 6 over 13. So I activate cosine -1, however you do that on your calculator. I type in the fraction, 6 over 13, and you can see it's a really, really long decimal, 62.51 is where I would stop. So in the second example right here, x is equal to 62.51 degrees. Okay, and so what that tells me is that in my right triangle, where that x is, that angle has a measurement of 62.51 degrees. All right, third example. So in the third example, I have a right triangle, and I'm going to draw my right triangle as such, like this right here, okay, like that. All right, I'm going to use a Greek letter to represent one of the non-right angles of the triangle, and I'm going to go ahead and use the Greek letter beta, okay, which kind of looks like, in the lowercase version, looks kind of like almost like a cursive B with a tail at the bottom left of it right there. So I'm going to put my beta symbol right here. So there's my beta symbol. Okay, now beta could just mean X. It could just mean theta. Really, it's just a symbol that represents that missing angle right there. Now, on the right diagonal side of this right triangle, I'm going to mark that as having a length of 17. On the other diagonal side of the triangle, I'm going to mark that as having a length of 9. And what I'm going to do in this equation is I'm going to identify the 17 as either the opposite side, adjacent, or hypotenuse side. The 17 would be identified as the opposite side. And the reason why it's the opposite side, because it's the side of the triangle that is across from my non-right angle that's missing, which we're going to refer to as beta. And then the side where the 9 is on, that side would be identified as the adjacent side. Okay, so notice that the only definition out of my trig functions that involves opposite and adjacent side is tangent. So this tells me that I am going to have to use the definition of tangent to create an equation. I'm going to use the diagram to help me fill out the equation, and then I'm going to solve it. Okay, so using the definition, I have tan, and then the definition says theta. Well, theta is your non-90 degree angle, which is that beta symbol right there. So I'm going to have tan beta is equal to, and then according to the definition, I'm going to write a fraction or a ratio. I'm going to put the opposite side's value on the numerator, which is 17. I'm going to put the adjacent side's value on the denominator, which is 9. So my equation is going to be tan beta is equal to 17 over 9, and I'm going to solve this equation for beta. And the way that I solve the equation for beta is that I need to mathematically eliminate tangent from my equation. And the way that I mathematically eliminate tangent is you're going to multiply tangent with the inverse tangent. So, but using the teeter-totter effect, if I multiply one side of the equation with tan minus 1, or the inverse tangent, I have to also multiply the other side of the equation. Now, what that accomplishes for me is that when you multiply tan minus 1 with tangent, they cancel each other out, and that would leave me now with the equation beta is equal to the inverse tangent, tan minus 1, of the fraction 17 over 9. Okay, now at this point, I use my calculator to figure out what is the tan minus 1 of the fraction 17 over 9, and that would tell me what my beta is in this problem. Okay, so I go to my calculator using whatever calculator you happen to have. I activate the tan minus 1 function, however you do that on your calculator, and then I type in the fraction 17 ninths. Whoops, what just happened? 17 ninths. There we go. Go back here, type in the fraction 17 ninths. And my calculator says, whoops, we're having a little bit of a formatting issue here. There we go, 17, hold on. That's not right. Okay. Let's try this again. Let's activate tan minus 1. There we go. Now I type in the fraction 17 ninths. Your calculator says the answer is 62.10. That's all you have to do is write the first two numbers after the decimal. So in this case, beta is equal to 62.10 degrees. And what I have found is I have figured out that that missing angle where the beta is 62.1 degrees. Inverse trig functions.